Hello there, and welcome to Sleepy Science Night. I'm so glad you found your way here tonight. The human mind is a mysterious place, especially when we close our eyes and drift into sleep. Tonight, explore one of consciousness' most beautiful puzzles: why our dreams slip away like morning mist, fading even as we try to hold them. Wherever you are right now, perhaps lying in bed with the lights dimmed low, or settling into your favorite quiet corner, allow yourself to rest here with me. Tonight, we'll journey through 100 fascinating truths about dreams and memory. From the sleeping brain's hidden choreography, to the chemistry of forgetting, to the strange moments when we become aware inside our own dreams. Each fact, a small step deeper into understanding the night. If this thoughtful journey through the mind helps you slow down, a gentle like helps more curious minds drift this way. One quiet tap, one sleepy soul at a time. It means the universe to us, but there's no pressure at all. Just knowing you're here is enough. For now, you don't need to do anything at all. Just let your shoulders soften. Let your breathing fall into its own rhythm. Imagine yourself floating in a space where thoughts bloom and dissolve like waves on a shore. Questions without answers. Mysteries without solutions. Now, if you're ready, let's begin our gentle exploration of why we forget our dreams. Now, if you'd like, close your eyes and take a deep breath. Imagine you're part of an endless stream of consciousness, where thoughts bloom and dissolve like waves, moving without boundaries, without destination. Let go of all limits. Let your mind drift through the space of awareness. And when you're ready, we'll begin. Research suggests that most dreams vanish within minutes of waking, with the vast majority fading before we can fully capture them. This rapid forgetting happens because the brain treats dreams differently than waking memories. During sleep, the hippocampus, our brain's memory-making center, operates in a unique mode that doesn't prioritize long-term storage of dream content. Instead, dreams seem to exist in a temporary mental space, like sketches drawn in sand, that the tide of waking consciousness washes away. This isn't a flaw or failure. It's a carefully designed feature of how our sleeping mind works. The brain has good reasons for letting most dreams fade, even if those reasons sometimes frustrate us when we wake with only fragments of a beautiful or meaningful dream still clinging to awareness. The hippocampus changes its function during different sleep stages. When we're awake, the hippocampus actively encodes new memories, stamping experiences into our long-term storage systems. But during REM sleep, when most vivid dreams occur, the hippocampus operates differently. Acetylcholine levels in the brain rise to nearly waking levels during REM sleep, and this biochemical shift affects how the hippocampus processes information. Instead of carefully filing away experiences for permanent storage, the hippocampus during REM sleep seems to replay and reorganize existing memories. Dreams may be a byproduct of this reorganization process. The content we experience in dreams reflects the brain sorting through memory fragments, but the hippocampus isn't engaged in the specific encoding mechanisms needed to remember the dream itself. It's a paradox. The organ responsible for memory is busy with other work while we dream. Waking up during or immediately after REM sleep improves dream recall. Studies from the Lyon Neuroscience Research Center found that people who naturally wake up more frequently during the night remember significantly more dreams than deep sleepers. This happens because memories require a brief period of conscious processing to transfer from short-term to long-term storage. When we wake directly from a dream, we catch it before it fully dissolves. The dream is still active in our working memory, like a program running in the background of a computer. If we remain asleep, that program closes without saving. But if we wake up, even for just a few seconds, we have a chance to acknowledge the dream's presence, and that acknowledgement acts like pressing a save button. Deep, uninterrupted sleepers may have just as many dreams, but they sail through them without these crucial moments of conscious contact. Specific neurons may actively promote forgetting during REM sleep. In 2019, a landmark study published in the journal Science identified a population of neurons that fire during REM sleep and appear to suppress memory formation. These are called MCH neurons, which stands for melanin concentrating hormone neurons. They're located in the hypothalamus and send connections directly to the hippocampus. When researchers artificially activated these MCH neurons in mice, the animals performed worse on memory tasks. When they silenced these neurons during REM sleep, memory actually improved. This suggests that the brain doesn't just passively fail to remember dreams. It actively works to forget them. Most dream content may not directly apply to our waking navigation of daily life, allowing the brain to clear mental space for what serves us most. These MCH neurons may help create that essential clearing, making room for memories that actually matter. Acetylcholine plays a surprising double role in sleep and memory. This neurotransmitter is essential for memory formation when we're awake. People with Alzheimer's disease, which involves damage to cholinergic systems, experience severe memory problems. During waking hours, acetylcholine helps the hippocampus encode new experiences. But during slow-wave sleep, acetylcholine levels drop to their lowest point, and this drop is actually necessary for memory consolidation. The brain uses this low acetylcholine period to transfer memories from temporary storage in the hippocampus to long-term storage in the cortex. Then, during REM sleep, acetylcholine surges back up to near-waking levels. But instead of encoding new memories, this REM sleep acetylcholine may help integrate and reorganize existing ones. Dreams occur during this high acetylcholine REM state, but the neurochemical environment, though similar to waking, serves a different function. The presence of acetylcholine without the encoding mechanisms means dreams feel vivid but don't stick in memory. The prefrontal cortex largely shuts down during REM sleep. This region at the front of the brain is crucial for logical thinking, self-awareness, and critically evaluating experiences. When we're awake, the prefrontal cortex acts like a skeptical editor, questioning what we perceive and deciding what's worth remembering. During REM sleep, activity in this region decreases significantly. This explains why dreams can be so bizarre and illogical without us noticing. We might fly through the air or talk to people who've been dead for years, and in the dream, it all seems perfectly reasonable. But the deactivation of the prefrontal cortex also affects memory. Without this region's input, the brain lacks the evaluative framework that normally helps decide which experiences to encode into long-term memory. Dreams wash over us without the critical analysis that might flag them as important or memorable. They're experienced, but not judged. And without judgment, they're less likely to be stored. Dream content often fades in a specific pattern. We don't lose all parts of a dream equally. Research shows that the emotional core of a dream, the feeling it generated, often lingers longer than specific details. You might wake up knowing you had an anxiety dream without remembering what you were anxious about. Or you might retain a sense of joy or peace without recalling the dream's actual events. This happens because different brain systems process different aspects of experience. The amygdala, which handles emotions, remains highly active during REM sleep. The emotional charge of a dream gets stamped more firmly into memory than the narrative details. Meanwhile, the specific images, conversations, and sequences of events depend more heavily on the hippocampus and cortex for encoding, and these regions aren't optimally configured for memory formation during dreams. The feeling outlasts the story because different neural pathways preserve them. Some people naturally remember dreams far more than others. Dream recall frequency varies dramatically across the population. A study published in 2025 using data from 258 individuals found distinct brain structure differences between high and low dream recallers. People who remember many dreams showed increased white matter integrity in specific regions: the orbitofrontal cortex, parahippocampal gyrus, superior parietal lobule, and occipital cortex. White matter consists of the brain's information highways, the bundled nerve fibers that connect different regions. Better developed connections in these areas seem to support more efficient dream recall. The orbitofrontal cortex, in particular, is involved in sensory processing and awareness during sleep. Some people's brains appear structurally better equipped to capture and hold on to dreams, like having a more sensitive recording device. This isn't something we choose. It's partly built into how our individual brains are wired. Norepinephrine, another key neurotransmitter, disappears almost completely during REM sleep. This chemical is associated with alertness and focus. It helps us pay attention to important information and consolidate memories when we're awake. During non-REM sleep, norepinephrine levels are low but present. During REM sleep, they drop to nearly zero. This absence has profound effects. Without norepinephrine, the sleeping brain lacks the biochemical signal that normally says, "This is important. Remember this." The absence of this neurotransmitter means that even intense or vivid dream experiences don't trigger the consolidation mechanisms that would normally preserve them. The brain experiences the dream, but doesn't receive the chemical instruction to store it. It's like experiencing an event while a crucial recording device is switched off. The experience happens, but the mechanism to preserve it is temporarily disabled. Dreams may serve a function specifically related to forgetting unnecessary information. Francis Crick, the co-discoverer of DN-as structure, proposed with his colleague Graham Mitchison that we dream in order to forget. Their theory suggested that dreams help eliminate spurious memories and unwanted neural connections formed during waking life. The brain generates millions of random connections each day, not all of them useful. If we kept every association, every fleeting thought, every tangential link between ideas, our mental life would become cluttered and confused. Dreams, in this view, act like a cleanup crew. They activate random patterns during sleep, and those patterns that aren't useful fail to be reinforced and gradually fade. The fact that we don't remember most dreams would be essential to this process. If we remembered every dream, we'd be cluttering our memory with the very noise the dreaming process was meant to clear away. Forgetting dreams, then, might not be a bug, but a feature. The transition from sleep to wakefulness involves a neurochemical flood that may wash away dreams. When we wake up, multiple neurotransmitter systems activate almost simultaneously. Norepinephrine returns. Acetylcholine shifts into its waking pattern. Dopamine and serotonin levels adjust, and the prefrontal cortex powers back up. This sudden cascade of changes creates a completely different brain state within seconds. Memories are state-dependent, meaning we remember things best when we're in a similar state to when we formed them. A dream formed in the unique neurochemical environment of REM sleep may be difficult to access once our brain shifts to the radically different waking state. It's like trying to recall something that happened in a foreign country after you've returned home and no longer speak the language. The memory exists, but the retrieval pathway has been disrupted by the transition between fundamentally different modes of brain operation. Dreams might actually help us process emotions precisely by being forgotten. A study published in 2024 in Scientific Reports found that dreaming plays an active role in emotional memory processing. Participants who reported dreaming showed improved processing of emotional memories compared to those who didn't report dreams. But here's the interesting part. The improvement came from processing the emotional content, while simultaneously weakening the memory of the specific events. Dreams allowed participants to work through feelings without necessarily retaining all the details of what they'd dreamed about. This suggests that forgetting dream content while retaining emotional learning might be therapeutically valuable. We process difficult emotions, update our emotional responses, and integrate emotional experiences, all while the specific dream scenarios fade away. The forgetting protects us from being overwhelmed by the processing work itself. Sleep stage timing affects dream content and memorability. REM sleep occurs in cycles throughout the night, with each REM period typically longer than the last. Early night REM periods are short, maybe 5 to 10 minutes. Late night REM periods can stretch to 30 minutes or more. Dreams from longer REM periods tend to be more elaborate, more bizarre, and sometimes more memorable, perhaps because there's more time for complex narratives to develop and for brief, spontaneous awakenings to occur. Dreams from early night REM sleep, by contrast, are often shorter and less vivid, and we're less likely to remember them because we're deep in the most restorative stages of sleep. The architecture of sleep itself influences both what we dream and whether we'll remember it. Our dream memory depends not just on what happens in our minds, but on when it happens during the night's journey through sleep stages. The brain's default mode network behaves differently during dreams. This network of brain regions typically activates when we're at rest, daydreaming, or thinking about ourselves and others. It's involved in self-referential thinking and memory. During REM sleep, the default mode network shows altered patterns of connectivity. Some connections strengthen, while others weaken. This reorganization may contribute to why dreams feel personally relevant, but also strange and disconnected from our normal sense of self. The same network that helps us form a coherent sense of identity when awake may, during sleep, contribute to the fluid, unstable sense of self we experience in dreams. And this altered configuration may not support the kind of memory encoding that preserves experiences for later recall. The default mode network is working during dreams, but it's working in a way that emphasizes processing over preservation. Young children remember dreams differently than adults. Infants and toddlers spend a much larger proportion of their sleep time in REM, suggesting they may have more dreams, but they can't report them. As language develops and children can describe their dreams, the reports are often shorter and less elaborate than adult dreams. Dream recall ability seems to develop alongside other cognitive capacities. Memory systems mature gradually throughout childhood. The hippocampus doesn't reach adult functionality until several years after birth. This means that even if children dream vividly, their developing memory systems may not encode those dreams effectively. Additionally, children may lack the metacognitive awareness that helps adults recognize and remember dreams. The ability to notice that you're having an experience worth remembering develops over time. This developmental trajectory suggests that dream forgetting isn't just about sleep neurochemistry, but also about the maturity of memory and awareness systems. Stress hormones affect dream recall in complex ways. Cortisol, the body's primary stress hormone, follows a daily rhythm, typically rising in the early morning hours. Higher cortisol levels can enhance certain types of memory formation, but may interfere with dream recall specifically. People experiencing high stress often report either dramatically increased dream recall, especially of nightmares, or dramatically decreased recall. The relationship isn't simple. Acute stress may wake people more frequently from REM sleep, providing more opportunities to catch dreams before they fade. Chronic stress, however, may disrupt sleep architecture and alter the neurochemical environment in ways that make dream memory more fragile. Studies show that elevated cortisol can interfere with the hippocampus' normal functions. Since dream recall depends on the hippocampus catching and holding dream content during those crucial moments of transition, stress-related changes to hippocampal function can make dreams even more elusive than usual. The phenomenon of lucid dreaming offers unique insights into dream memory. Lucid dreams occur when a person becomes aware they're dreaming while still asleep. A groundbreaking 2025 study, led by Chate Demirel, analyzed EEG data from multiple laboratories and identified distinct brain activity patterns during lucid dreaming. The research showed increased beta band activity in the right temporal and parietal regions, including the temporoparietal junction. Beta waves are associated with conscious thought and self-awareness. Lucid dreamers also showed enhanced gamma connectivity, particularly in the precuneus, a region involved in self-referential thinking. What's fascinating for memory is that lucid dreamers report better dream recall. When the brain achieves awareness within the dream state, it appears to engage some of the same circuits used for conscious memory formation when awake. This supports the idea that dream forgetting relates to the absence of conscious awareness and the specific neural signatures that normally accompany memorable experiences. Sleep deprivation initially impairs memory, but sometimes increases dream recall. When people are severely sleep deprived, their cognitive functions decline, including memory. Yet paradoxically, dream recall often increases during the first REM-rich sleep period after deprivation. This happens because the body enters REM rebound, generating especially long and intense REM periods to compensate for lost REM sleep. These extended REM periods produce more elaborate dreams, and the increased intensity, combined with heightened cortical activation patterns, can make them more likely to be recalled upon waking. Additionally, sleep-deprived people wake more frequently from light sleep stages, providing more opportunities to catch dreams. This doesn't mean sleep deprivation helps memory overall. It impairs it significantly. But it does illustrate how the timing and intensity of sleep stages interact with dream recall in unexpected ways. The brain's visual cortex activates intensely during REM dreams. Neuroimaging studies show that the visual areas at the back of the brain light up during REM sleep, almost as brightly as when we're awake and actually seeing. This explains why dreams are so visual, so filled with images, colors, scenes, and movements. We're not receiving visual input from our eyes, which are closed, yet we experience vivid visual content. The brain generates this imagery internally. However, this visual activation doesn't automatically translate to visual memory. Seeing something in waking life activates both the visual cortex and memory systems simultaneously. During dreams, the visual cortex fires intensely, but the memory systems aren't engaged in their normal encoding mode. We see elaborate dream imagery, but without the memory machinery running properly. These visions slip away. It's like watching a movie on a screen that can't record. Temperature affects sleep quality and indirectly influences dream recall. The body's core temperature drops during sleep, and this decrease is necessary for deep, restorative sleep. If the sleeping environment is too warm or too cold, it can cause brief awakenings or lighter sleep. These microarousals increase the chances of waking from or near REM sleep, which means more opportunities to remember dreams. People who sleep in well-regulated, comfortable temperatures tend to sleep more deeply and continuously. They may have just as many dreams, but they're less likely to remember them because they're not waking at the right moments. This might seem like a trivial detail, but it illustrates how dream recall depends on many factors beyond the dream itself. The physical environment, body physiology, and the delicate timing of sleep stage transitions all play roles in determining which dreams we'll remember and which will fade into the forgotten vastness of the night. Alcohol consumption severely impairs dream recall. While alcohol can help people fall asleep faster, it fundamentally disrupts sleep architecture. Alcohol suppresses REM sleep during the first half of the night. Later, as the body metabolizes the alcohol, REM sleep rebounds, sometimes producing intense and vivid dreams. However, alcohol also fragments sleep and impairs the hippocampus function. Even when REM sleep occurs, the memory encoding systems work less effectively under alcohol's influence. People who drink before bed often report either no dream recall or only fragmented, disturbing dream images. This happens because alcohol interferes with both the generation of normal REM sleep and the brain's ability to process and store the experiences that do occur. The impairment extends beyond just dreams. Alcohol affects memory consolidation for waking experiences as well. But dreams, already fragile and difficult to capture, become even more ephemeral under alcohol's influence. Certain medications can dramatically alter dream recall and content. Antidepressants, particularly SSRIs, often increase dream vividness and recall. Some users report extremely vivid, bizarre, or emotionally intense dreams. This likely happens because these medications affect neurotransmitter systems involved in sleep and memory. Conversely, medications that block acetylcholine, like some antihistamines or drugs for Parkinson's disease, can reduce REM sleep and dream recall. Beta blockers, used for blood pressure, may affect norepinephrine and also influence dreaming. Every medication that crosses into the brain and affects neural signaling has the potential to alter the delicate neurochemistry of sleep. Most people don't consider how their medications might change their relationship with dreams. but our inner nightlife is sensitive to these chemical influences. The same drugs that help with physical or mental health conditions during waking hours may quietly reshape the landscape of sleep and dreaming. The DREAM database, established by an international team in August 2025, represents a major advance in dream research. Coordinated by Monash University with contributions from 37 institutions, including Paris Brain Institute. This database centralizes EEG recordings and dream reports from over 500 participants and 2,500 recordings. One of the database's goals is to help answer fundamental questions. Why do some people remember dreams every night, while others rarely do? Why are we sometimes conscious during sleep and sometimes not? The standardized data allows researchers to compare brain activity patterns across different populations and conditions. This large-scale approach was necessary because individual dream studies typically have small sample sizes. By pooling data, researchers can identify patterns that would be invisible in smaller studies. The DREAM database is designed to grow indefinitely, incorporating new findings as they emerge. It may eventually help us understand not just why we forget dreams, but what dreams themselves are for. Dream content often incorporates recent experiences, but in transformed ways. This phenomenon, called the day residue effect, shows that fragments of recent waking life appear in dreams, but rarely directly. Instead, the brain seems to remix these elements. You might dream about a person you saw briefly on the train, combined with a location from childhood, engaged in an activity from yesterday's work project. The bizarre combinations may represent the brain's attempt to find connections between new experiences and existing memory networks. However, this transformational process may also make dreams harder to remember. When dream content is too far removed from actual experience, the waking mind struggles to recognize or categorize it. Memories depend partly on having good retrieval cues, mental handles we can grab to pull the memory back into consciousness. But if a dream has been transformed beyond recognition, the normal cues don't work. We lose the dream not because it wasn't vivid, but because we can't find the right mental pathway to retrieve it. Practice and intention can improve dream recall. People who keep dream journals and commit to remembering their dreams often develop better recall over time. This happens through several mechanisms. The act of writing dreams down reinforces neural pathways associated with dream memory. Setting an intention before sleep, such as, "I will remember my dreams," activates metacognitive systems that may remain partially active during sleep. People who value their dreams and think about them frequently develop more sophisticated mental models for categorizing and storing dream experiences. Some researchers compare it to developing any skill. Dream recall is partly an ability that can be trained. The brain's plasticity means that repeated attention to dreams can strengthen the networks involved in capturing them. However, even skilled dream recallers still forget most dreams. The brain's fundamental architecture during REM sleep limits how much can be preserved. But within those limits, practice makes a difference. The mind learns to be more alert to these ephemeral nighttime experiences. Let's pause here and notice your body. As you breathe out slowly, appreciate each tiny cell inside. Trillions of organisms working in silence. Heart beating, lungs breathing, brain dreaming, all without your command. Notice the gentle sensations on your skin, in your muscles, along your spine. You are a complete ecosystem, diverse, self-balancing. Your brain processes thousands of dreams across a lifetime. Most fade, but their work remains, organizing memories, processing emotions, clearing mental clutter. Trust this. Your mind knows what to keep and what to let go. Now we continue. The timing of awakening profoundly affects dream memory. Research shows that waking naturally from REM sleep provides the best chance for dream recall. Alarm clocks, however, often jar us from whatever sleep stage we're in, without regard for our sleep cycles. If an alarm wakes you from deep, slow-wave sleep, you're unlikely to remember any dreams, even if you had vivid REM dreams earlier in the night. Some sleep apps and devices now attempt to wake people during lighter sleep stages, ideally near the end of a REM period. These smart alarms may improve dream recall simply by respecting the brain's natural rhythms. The act of waking shapes what we remember from the night. An abrupt, startling awakening floods the brain with stress hormones and may override whatever dream memory was present. A gentle, gradual awakening allows the transition to occur more smoothly, preserving some of the night's experiences. Dreams early in the night differ from dreams near morning. Early night REM periods tend to produce dreams that incorporate more recent experiences and are often shorter and less emotionally intense. Late night REM periods, occurring after several sleep cycles of memory processing, tend to generate longer, more bizarre, more emotionally rich dreams. This pattern reflects the brain's progressive work through the night. Early sleep is dominated by slow-wave sleep, when the brain consolidates memories from the day. The brief REM periods that interrupt this process contain dreams that reference this consolidation work. By morning, after hours of memory processing, REM periods expand and dreams become more elaborate. These late morning dreams, being longer and more vivid, might seem more memorable. But we also wake from them into full waking consciousness, and the neurochemical transition can erase them just as thoroughly as shorter early night dreams. The language we use to describe dreams influences how we remember them. Cultures vary widely in how much importance they place on dreams and how elaborately people discuss them. Some cultures have rich vocabularies for different types of dreams and dream elements. Others treat dreams as unimportant noise from sleep. These cultural differences affect dream recall. People from cultures that value dreams report remembering more dreams, and their reports are more detailed. This isn't just about what people choose to report. The expectation that dreams are meaningful and worth attending to appears to actually improve the brain's ability to encode them. Conversely, in cultures that dismiss dreams as meaningless, people may literally forget them more quickly because there's no cultural framework supporting their retention. Memory is shaped by meaning. If something seems meaningless, the brain deprioritizes it. If it seems significant, memory systems engage more fully. Blind individuals dream differently, and their recall patterns reveal interesting insights about dream memory. People who lost their sight after age 5 or 6 typically continue to have visual dreams, pulling from their stored visual memories. Those born blind or who lost sight very early report dreams without visual content but rich in sound, touch, and emotion. Interestingly, blind individuals report similar rates of dream recall to sighted people. This suggests that the visual content of dreams, while striking, isn't necessary for the dreams to be memorable. What matters more for recall are factors like emotional intensity, the narrative quality of the dream, and whether the person wakes at an opportune moment. Blind individuals' dream experiences remind us that dreams aren't fundamentally about images, even though most people experience them that way. They're about the brain's capacity to simulate experience. And whether or not we remember them depends on general memory mechanisms rather than any specific sensory content. The role of slow-wave sleep in dream forgetting is indirect but important. During slow-wave sleep, the brain shows large, synchronized waves of neural activity. This is the deepest stage of sleep, when the body repairs itself and the brain consolidates memories. Acetylcholine drops to its lowest levels, and this low level is crucial for transferring memories from the hippocampus to the cortex. But slow-wave sleep isn't when we typically have vivid dreams. Dreams occur mostly in REM sleep. However, the work that happens during slow-wave sleep affects REM dreams. If slow-wave sleep is disrupted, the subsequent REM periods may be affected, potentially altering both dream content and recall. Additionally, the transition from slow-wave to REM sleep involves significant neurochemical changes. If these transitions are abrupt or incomplete, it might affect the brain's ability to form stable dream memories. The sleep stages interact in complex ways, and dream memory depends on the quality of the entire night's sleep architecture. Recurring dreams might be remembered better precisely because they recur. Some people experience the same dream, or variations on a theme, repeatedly over months or years. These dreams are often remembered more clearly than one-time dreams. Several factors may explain this. First, repetition itself strengthens memory. Each time the dream recurs, it's like rehearsing the same material, which naturally leads to better encoding. Second, recurring dreams often reflect ongoing concerns or unresolved issues, giving them emotional weight that aids memory. Third, people who notice they're having a recurring dream become more alert to it, both within the dream and upon waking. This increased attention engages memory systems more fully. Recurring dreams demonstrate that dreams aren't completely forgotten if they carry enough significance or repeat often enough. The brain's general forgetting mechanism for dreams can be partially overcome when a dream pattern establishes itself strongly enough to become a recognizable feature of someone's mental life. Pregnancy and hormonal changes can dramatically affect dream content and recall. Pregnant individuals often report increased dream vividness and better recall, especially in the third trimester. This may relate to several factors. Pregnancy causes frequent nighttime awakenings due to physical discomfort, providing more opportunities to catch dreams. Hormonal changes affect neurotransmitter systems involved in sleep and memory. Progesterone, which rises during pregnancy, influences sleep architecture. Additionally, the psychological significance of pregnancy may make dreams feel more meaningful, encouraging people to pay more attention to them. After giving birth, many people report a period of fewer remembered dreams, possibly due to severe sleep disruption and exhaustion. This natural experiment in how changing biology affects sleep demonstrates how fragile dream memory is. When sleep is disrupted or hormonal environments shift, our relationship with dreams shifts accordingly. The brainstem's role in REM sleep generation affects dream memory indirectly. A region called the pons initiates REM sleep, by sending signals that suppress muscle tone and activate the cortex in the characteristic pattern of REM. Damage to specific areas of the brainstem can eliminate REM sleep entirely, which also eliminates most vivid dreaming. But even with an intact brainstem, the signals that generate REM don't include specific instructions to remember the resulting experience. REM sleep evolved primarily for other functions related to brain development and memory consolidation, not specifically to produce conscious experiences. Remember, dreams may be an almost accidental byproduct of the brain's activation during REM. If dreams are essentially side effects of neural activity serving other purposes, it makes sense that the brain wouldn't automatically preserve them. The neurochemical state that generates dreams is optimized for processing existing memories, not for creating new episodic memories of the dreams themselves. Déjà rêvé, the feeling of already dreamed, suggests hidden dream memories. Some people occasionally experience déjà rêvé, the sensation that a current waking experience was previously dreamed. This is distinct from regular déjà vu, which is the feeling of having lived through the exact moment before. Déjà rêvé specifically implicates dreams. The phenomenon is puzzling because the person usually can't recall the specific dream that supposedly predicted the current moment. One explanation is that we actually do store more dream content than we consciously access. Some dream memories may exist below the threshold of conscious recall, but can still generate feelings of familiarity when triggered by similar waking experiences. This would suggest that dream forgetting isn't absolute. The memories aren't completely erased. They're just difficult to retrieve voluntarily. They may resurface as vague feelings rather than clear recollections. This possibility hints at a vast reservoir of dream experiences that shape our mental life without our awareness. Narcolepsy, a disorder involving dysregulated REM sleep, offers insights into dream memory. People with narcolepsy may enter REM sleep directly from wakefulness, skipping the normal progression through sleep stages. They often report vivid, bizarre hypnagogic hallucinations as they fall asleep, which are essentially waking dreams. Many individuals with narcolepsy have excellent dream recall, possibly because their REM periods intrude into wakefulness, and they wake frequently from dreams. This shows that when REM sleep occurs closer to waking consciousness, dream recall improves dramatically. The disorder essentially blurs the boundary between waking and dreaming, and in doing so, it makes dreams more memorable. For most people, this boundary is sharp, and the transition erases dreams. For narcoleptics, the blurred boundary preserves them. This isn't pleasant. It causes significant impairment, but it demonstrates how normal dream forgetting depends on maintaining clear separation between sleep and wakefulness. Dream content can be influenced by external stimuli, but we usually don't remember these dreams any better. Research shows that sounds, lights, touch, or even smells can sometimes be incorporated into dreams without waking the sleeper. A ringing phone might become a doorbell in a dream. But despite this direct connection between external reality and dream content, these stimulus-influenced dreams aren't usually remembered better than purely spontaneous dreams. The incorporation happens unconsciously. The sleeping brain weaves external information into its ongoing narrative without engaging the memory systems that would preserve the experience. This demonstrates that dream forgetting isn't about the dreams lacking content or being somehow less real than waking experiences. Even dreams that directly respond to actual sensory input, fade just as quickly as purely internally generated dreams. The problem isn't what happens in the dream. It's what doesn't happen in the memory systems during REM sleep. The concept of dream incubation, cultivating specific dream content, sometimes improves recall. Some people practice choosing what they'll dream about before sleep. They might think about a problem they want to solve or a person they want to see in dreams. Research shows this can influence dream content. Interestingly, people who successfully incubate dreams often report better recall of those dreams. This may happen because the pre-sleep attention primes memory systems to be more alert to dream content. By thinking deliberately about what you hope to dream, you're essentially creating retrieval cues in advance. When the dream occurs, these pre-established cues may help the experience stick in memory better. It's like telling yourself to remember something before it happens. The intention sets up neural patterns that facilitate later recall. However, this effect is modest. Dream incubation doesn't overcome the fundamental neurochemical barriers to dream memory. It just works within them slightly more effectively. Sleep paralysis episodes are remembered vividly, revealing what's different about regular dreams. Sleep paralysis occurs when someone wakes up before the muscle suppression of REM sleep has ended. They're consciously awake, but temporarily unable to move. These episodes are often terrifying and hallucinatory, with people reporting sensing a presence in the room or pressure on their chest. Unlike regular dreams, sleep paralysis episodes are remembered with clarity and detail. This happens because the person is genuinely awake, with all their waking neurotransmitter systems active and their memory encoding systems fully engaged. The experience occurs in REM-like brain state, but with conscious awareness. This contrast highlights why regular dreams fade. During normal REM sleep, we lack this crucial element of waking consciousness and the memory encoding it enables. Sleep paralysis is memorable precisely because it bridges the gap between the REM state and waking awareness, engaging memory systems that regular dreams bypass. The sleeping brain's sense of time differs from waking time, affecting dream memory. Time perception in dreams is notoriously unreliable. A dream that seems to span hours might occupy only minutes of REM sleep, or a brief instant in a dream might feel extended and drawn out. This temporal distortion creates problems for memory. Waking memory relies partly on temporal context, knowing when something happened and in what sequence. Dreams lack reliable temporal markers. Events blur together. Sequences scramble. Cause and effect relationships become confused. When we try to remember a dream upon waking, we're trying to impose our waking sense of linear time onto an experience that didn't follow those rules. The mismatch makes the dream harder to hold on to. It's like trying to draw a map of a place where space itself kept changing. Our waking memory systems expect a certain structure, and dreams don't provide it. Technology is beginning to allow researchers to decode dream content from brain activity. In several recent studies, scientists used machine learning to predict what category of object someone was dreaming about based on their brain activity patterns. This requires waking the person repeatedly and asking what they were dreaming, then correlating their reports with brain scans. The success is still limited and requires many trials, but it demonstrates that dream content does leave traceable patterns in neural activity. These patterns exist, even if the dreamer doesn't consciously remember them. This raises a fascinating possibility. Maybe our dreams are stored somewhere in the brain, just in a format we can't consciously access. Perhaps future technology could help us read dream memories that we've forgotten. Or perhaps the patterns researchers detect aren't true memories at all, but simply echoes of neural activity that dissipate quickly. Either way, the research confirms that something about our dreams persists in the brain, at least briefly, whether or not we consciously recall it. If you're still here with me, thoughts still flickering like candlelight, just notice. Don't judge. Just notice where your mind is. We're exploring consciousness itself, the very thing doing the exploring right now. Strange, beautiful, and perfectly calm. Let's drift onward together. The evolutionary purpose of dreaming remains debated, which affects how we think about dream forgetting. Some researchers argue dreams helped our ancestors practice threat responses in a safe, simulated environment. Others suggest dreams are merely random neural noise with no function. Still, others propose that dreams integrate memories and process emotions. If dreams evolved for a specific purpose, that purpose might not require us to remember them. Just as your liver processes toxins without you being aware of it, your dreaming brain might process information without creating lasting memories of the processing. The forgetting might be intentional, keeping the workspace clear. Alternatively, if dreams are just noise, an unintended byproduct of brain activity, there would be no evolutionary pressure to develop mechanisms for remembering them. Either way, the ease with which we forget dreams suggests they weren't designed to be remembered. Musical dreams can be particularly vivid, but still fade quickly. Some people dream of hearing music, sometimes pieces they know, sometimes completely original compositions. Musicians report these dreams more frequently than non-musicians. The auditory cortex activates during these dreams, and the experience can feel as real as listening to actual music. Yet, even these distinctive, emotionally powerful dreams usually fade rapidly upon waking. Occasionally, someone remembers enough to write down a melody, but more often, the music is lost. This shows that even when dreams have unique sensory qualities that might seem memorable, the fundamental forgetting mechanism still operates. The content type doesn't matter as much as the brain state in which it occurs. Beautiful music, complex narratives, profound insights, all are subject to the same neurochemical limitations that make dream memory so fleeting. Nightmares tend to linger in memory more readily than gentle dreams. The amygdala, which processes fear and other strong emotions, is highly active during REM sleep. Nightmares activate the amygdala intensely and often cause partial or full awakening. This combination of strong emotion and awakening makes nightmares more likely to be encoded into memory. Additionally, nightmares have survival relevance. Our ancestors who remembered threatening dream scenarios might have been better prepared for actual threats. While nightmares can be distressing, their memorability might have once been adaptive. Today, when nightmares become too frequent or vivid, they can contribute to sleep disorders like PTSD-related nightmares. But the underlying mechanism that emotionally intense dreams are remembered better reveals how emotional salience can partially overcome the normal dream forgetting process. Fear cuts through the haze and leaves a mark. Dream reports get less detailed the longer someone waits after waking to describe them. Studies show that if you wake someone from REM sleep and immediately ask for a dream report, they can provide detailed, elaborate narratives. Wait 5 minutes, and the report becomes shorter. Wait 15 minutes, and large sections have vanished. By an hour later, most people remember only fragments or nothing at all. This rapid decay curve shows that dream memories exist briefly but deteriorate quickly unless actively maintained. The decay follows a pattern similar to very short-term working memory, suggesting that dreams never fully transition into the more stable, long-term memory systems. They linger in a temporary buffer, and unless something happens to transfer them forward, like writing them down or telling someone about them, they simply degrade and disappear. False awakenings reveal the complexity of consciousness and memory in sleep. A false awakening is when you dream that you've woken up, often in your own bedroom, going through morning routines, only to eventually wake up for real and realize the first awakening was part of the dream. These experiences can be disorienting and are often remembered quite clearly, perhaps because they mimic waking consciousness so closely. The brain briefly engages some of the same patterns it uses in actual waking, including better memory encoding. False awakenings demonstrate that the dreaming brain can temporarily activate wake-like states, and when it does, the experience becomes more memorable. This supports the idea that dream forgetting relates to the specific state of consciousness during REM sleep. When that state shifts even slightly toward waking patterns, memory improves. True sleep, and thus true dream forgetting, requires maintaining a state quite distinct from wakefulness. Some people claim they never dream, but research shows this is almost certainly false. Lab studies confirm that everyone with a normal brain enters REM sleep multiple times per night. When non-dreamers are awakened from REM sleep, they can usually report dream content. What they mean, then, is that they never remember dreams spontaneously. This extreme forgetting might relate to how deeply they sleep, how their brain transitions between sleep and waking, or simply how much attention they pay to dreams. Some people's brains may be particularly efficient at maintaining the barrier between sleeping and waking consciousness, which prevents dream memories from crossing over. This isn't better or worse than remembering dreams frequently. It's simply a different pattern. But it demonstrates that dream forgetting exists on a spectrum. Some people forget nearly all their dreams immediately, while others retain vivid memories of multiple dreams nightly. Most of us fall somewhere in between. The sense of self can be strange or absent in dreams, which affects memory. In waking life, our sense of being a continuous person, the same individual from moment to moment, provides a stable framework for memory. We remember things that happened to us. In dreams, the sense of self is fluid. You might be yourself but younger, or yourself with different characteristics. Or sometimes, you might observe yourself from outside as if you were someone else. This instability in self-representation creates problems for memory. When you wake up, your normal, unified sense of self returns, but the dream occurred to a somewhat different version of you. The waking self may not fully identify with or claim ownership of the dream self's experiences. This discontinuity makes it harder for dream experiences to integrate into your autobiographical memory. The waking you may struggle to remember what happened to the dream you, because, in some fundamental way, they don't feel like the same person. Dream sharing in relationships and families can strengthen dream memory. When people regularly tell their dreams to partners, family members, or friends, several things happen. The act of verbally reporting the dream reinforces the memory, helping it stick. Social interest in dreams provides motivation to remember them. If you know someone wants to hear about your dreams, you're more likely to pay attention when you wake up. Additionally, others, reactions and questions can help elaborate the dream memory, filling in details you might otherwise lose. In cultures or families where dream sharing is common, dream recall tends to be higher across all members. This social dimension of memory shows that remembering isn't purely individual. We remember better what our communities value. Dreams, when given social importance, become more memorable. When treated as private nonsense, they fade more completely. Certain brain injuries can eliminate dreaming or selectively impair dream recall. Damage to specific regions, particularly the junction of the parietal, temporal, and occipital lobes, can cause a condition where people stop reporting dreams entirely. When awakened from REM sleep, they describe nothing, or only vague thoughts without imagery. This suggests that generating vivid dream experiences requires intact function in these association areas. Conversely, damage to different regions, particularly in the frontal lobes, can impair memory while leaving dreaming intact. These patients report having vivid dreams, but forgetting them even more rapidly than normal. Such cases demonstrate that dreaming and dream memory are separable. The brain systems that create dreams are different from the systems that remember them. You can have one without the other. This separation helps explain why normal people forget most dreams. The systems work together imperfectly, with the memory systems underengaged during the dream state. Dreams can incorporate abstract thoughts and concepts, not just images. While we often think of dreams as visual movies, dream content includes reasoning, problem-solving, conceptual understanding, and non-sensory information. You might dream of understanding a complex idea without any visual representation. These abstract dreams are particularly difficult to remember because they lack the concrete sensory details that usually help anchor memories. A visual scene provides retrieval cues. The image itself helps you recall it. But an abstract understanding or a pure feeling of knowing something doesn't leave the same hooks in memory. When you wake up, you might retain a sense that you understood something important, but the specific understanding itself has evaporated. This is frustrating for people who feel they've solved problems or gained insights in dreams. The solution was there, briefly, but the brain's normal memory systems couldn't grab onto something so conceptual and non-physical to preserve it. We've traveled halfway, and in this moment, let each breath guide you to realize time is yours, a separate stream that only you are living, while consciousness continues to flow, to dream, to forget, to remember. This second, you're breathing. Listening is unique. Your dreams fade each morning, but this is not loss. This is the mind refreshing itself, clearing space for new experience. Cherish the present moment, knowing that right now, your awareness is unique in the universe. And we continue drifting. The phenomenon of prospective dreaming suggests some dream memories do persist. Some people report dreams that seem to anticipate future events. While most of these are coincidence or false memories, they hint that dreams occasionally leave lasting impressions. A dream that later matches a real experience becomes highly memorable because of the emotional impact. This selective memory creates an illusion that prophetic dreams are common. In reality, we forget thousands of dreams that didn't match anything. But the few that seem to connect to future events get remembered precisely because of that connection. This shows how motivation and meaning strengthen memory even for dreams. When something feels significant, the brain allocates more resources to preserving it. The default mode network's activity during REM sleep may actually facilitate forgetting. This network is involved in self-referential thought and memory consolidation during waking. During REM, it shows altered connectivity patterns. Some researchers propose that these patterns reflect the brain actively reorganizing memories. And in that process, the specific dream content gets discarded as the underlying emotional or cognitive work gets integrated. The dream is the processing, not the product. Once the processing is complete, the dream itself becomes unnecessary and fades away. Like scaffolding, used to build a structure and then removed, dreams support memory work, but don't need to be remembered themselves. Sensory deprivation can intensify dreams and sometimes improve recall. People who spend time in isolation tanks or quiet retreat environments often report more vivid dreams and better memory of them. With reduced external stimulation, the brain may become more attentive to internal experiences. Dreams might stand out more sharply against a background of reduced waking stimulation. Additionally, people in retreat settings often have fewer competing demands on memory. Without the constant influx of new waking experiences, dream memories face less interference and may persist longer. This suggests that modern life's sensory overload may contribute to dream forgetting. Our brains are so busy processing waking experiences that dreams get crowded out. Children's nightmares and night terrors differ in memorability. Night terrors occur during deep, slow-wave sleep, not REM sleep. The child appears terrified, but is actually asleep and typically has no memory of the episode in the morning. Nightmares, by contrast, occur during REM sleep and are often remembered, at least partially. This distinction illustrates how memory depends on sleep stage. Night terrors happen in a sleep stage that doesn't support memory formation at all. Nightmares happen during REM, which allows some memory encoding, especially if the child wakes up frightened. The emotional intensity of nightmares helps them stick in memory better than neutral dreams. For children, this can be distressing, but it also demonstrates the principle that emotional salience improves dream recall. Meditation practices can influence dream, recall, and lucidity. People who meditate regularly, particularly practices that emphasize present moment awareness, often report better dream recall and increased lucid dreaming. Meditation may strengthen metacognitive awareness, the ability to observe your own mental states. This skill, cultivated during waking meditation, can transfer to sleep. A mind trained to notice its own thoughts may notice when it's dreaming. Additionally, meditation affects sleep, architecture, and neurotransmitter systems. These changes might create conditions more favorable for dream memory. The relationship between meditation and dreams is complex, but it demonstrates that mental training can influence even the ephemeral realm of dream experience and memory. Color perception in dreams varies between individuals. Some people dream in vivid color, others in muted tones, and a small percentage report black and white dreams. Interestingly, studies show that people who grew up watching black and white television are more likely to report black and white dreams. This suggests dreams draw on our experience and expectations of media and reality. Regardless of color, dream recall doesn't differ significantly. Color dreams aren't necessarily remembered better than black and white dreams. What matters more is emotional content, narrative coherence, and timing of awakening. This shows that specific sensory qualities, while making dreams feel more or less vivid in the moment, don't determine whether they'll be remembered. Dream content reflects cultural and personal symbolism, but interpretation doesn't improve memory. Humans have always tried to find meaning in dreams. Ancient civilizations developed elaborate dream interpretation systems. Modern psychology explores dreams as windows into the unconscious. However, analyzing dreams doesn't necessarily help you remember them better. In fact, forcing interpretation can sometimes interfere with pure recall. The analytical process activates different brain systems than simple memory retrieval. Some people find that trying too hard to understand a dream actually makes it slip away faster. The meaning of a dream, if it has any, exists separately from the memory of it. You can have meaningful dreams and forget them, or remember meaningless dreams perfectly. The transition from REM to waking involves a cascade of neurochemical changes that wipe the slate clean. Within seconds, multiple neurotransmitter systems shift gears. This dramatic transition may serve a purpose. It helps keep dream confusion from bleeding into waking cognition. If dreams persisted too strongly in memory, we might find it difficult to separate real experiences from dream imagery. The forgetting mechanism protects our ability to navigate the real world. In pathological conditions where this boundary blurs, such as some forms of psychosis or severe sleep disorders, the confusion can be deeply disorienting. Normal dream forgetting, then, isn't a bug. It's a feature that maintains clear boundaries between different states of consciousness. Dreams can continue if briefly interrupted. If you wake up partway through a dream and fall back asleep quickly, sometimes the dream resumes. This suggests the dream exists as an ongoing neural pattern that can be reactivated. However, even when a dream continues, memory of it usually doesn't improve. The brief waking provides an opportunity to capture the dream, but most people are too groggy to take advantage of it. By the time they fully wake later, both parts of the dream have faded. This shows how fragile dream memory is. Even with multiple chances to remember, even with the dream occurring in segments, the fundamental forgetting mechanism still operates. Age affects dream content and recall in complex ways. Young adults tend to have more vivid dreams and better recall than elderly people. This may relate to changes in sleep architecture with aging. Older adults spend less time in REM sleep and more time in lighter stages. Their REM periods may be less intense, producing less vivid dreams. Additionally, age-related changes in memory systems affect dream recall. The same processes that make it harder to form new waking memories also make dream memory more difficult. However, some older adults report that dreams from their youth are surprisingly vivid in memory, suggesting that dreams from early life, if remembered at all, can persist for decades. The phenomenon of hypnagogic and hypnopompic hallucinations straddles the boundary between waking and dreaming. Hypnagogic experiences occur while falling asleep, hypnopompic while waking up. These can include vivid imagery, sounds, or sensations. Because they occur during transitions rather than deep sleep, they're often remembered more clearly than regular dreams. The brain is partly awake and partly asleep, creating a hybrid state. Memory systems are more engaged than during full REM sleep. These experiences show that the closer dreaming gets to waking consciousness, the more memorable it becomes. True, deep dreams, occurring in solid REM sleep, are furthest from waking and thus most forgettable. Dreaming about learning can sometimes improve actual performance, but the dreams themselves are usually forgotten. Studies show that people who dream about tasks they're learning, like navigating a maze or playing a musical instrument, often perform better after sleep. The dream content reflects memory consolidation in progress. However, participants often don't remember the specific dreams where they practiced these skills. The improvement happens whether or not they consciously recall the dreams. This demonstrates that dreams can serve functions below the level of conscious awareness. The work gets done, the benefit accrues, but the actual dream experience remains ephemeral. Language and verbal content in dreams can be surprisingly sophisticated, yet we often lose it. People report having complex conversations in dreams, sometimes in languages they barely know while awake. The dreaming brain seems capable of generating fluent speech and comprehension. Yet, upon waking, the specific words usually can't be recalled. You might remember that you had a conversation, who you spoke with, maybe even the general topic, but the actual dialogue vanishes. This is similar to how we often forget the specific words of waking conversations while remembering their general content. But with dreams, the loss is more complete. Even immediately upon waking, the words are gone. Physical movement during dreams is inhibited, but the intention to move remains. During REM sleep, the brainstem actively paralyzes most voluntary muscles. This prevents us from acting out our dreams physically. However, the motor cortex still generates movement commands. In dreams, you might run or fight or dance, and your brain creates the experience of movement, even though your body stays still. This disconnect might contribute to dream forgetting. Waking memories often include proprioceptive information, the sense of our body in space. Dreams lack this anchoring. When you wake, your body hasn't actually gone anywhere or done anything. The discrepancy between dream experience and physical reality may make dreams harder to remember and integrate into your personal history. Shared or collective dreaming, while fascinating to discuss, probably reflects coincidence and false memory more than actual shared experience. Occasionally, friends or family members report dreaming similar content on the same night. These reports are intriguing but rare, and usually the similarities are vague. More likely, people unconsciously shape their memory of dreams to match others' reports after the fact. Memory is reconstructive, not a perfect recording. When someone tells you their dream, it can alter your memory of your own dream. This malleability of dream memory shows how unstable these memories are. They're not fixed facts, but mutable narratives that can be influenced by suggestion, expectation, and social context. Animals also appear to dream, and studying them provides insights into dream function. Dogs twitch and move their paws during sleep, suggesting they're dreaming. Rats show brain activity during sleep that matches patterns from maze running while awake. Since animals can't report their dreams, we can't know if they remember them in any meaningful sense. But studying animal sleep suggests that whatever dreaming accomplishes, it probably doesn't require conscious awareness or memory of the experience. The benefits of dreaming occur at a neural level, in the reorganization of connections and consolidation of memories. The subjective experience we have of dreams may be secondary to these processes, a side effect rather than the main event. Dream diaries can become remarkably detailed, yet most entries describe dreams that would have been forgotten otherwise. People who keep consistent dream journals often build archives of hundreds or thousands of dreams. Reading back through old entries, they encounter dreams they've completely forgotten, even though they wrote detailed accounts. This shows that writing down a dream doesn't guarantee long-term memory of it. The act of writing captures it temporarily, but unless you regularly review entries, even written dreams fade from personal memory. The journal becomes an external storage device for experiences your brain chose not to preserve long-term. This external memory suggests that while the mind is willing to let dreams go, we can intervene and save them if we choose. The intensity of emotion in a dream doesn't always correlate with memorability. You might have a dream that feels emotionally overwhelming in the moment, yet forget it completely by morning. Conversely, an emotionally neutral dream might stick with you for unclear reasons. While emotion generally aids memory, the relationship isn't absolute. Other factors matter: timing, sleep stage, overall sleep quality, stress levels, and simple chance. Sometimes a dream memory survives not because it was particularly intense, but because something random activated the right neural pathways at the right moment. This unpredictability is part of why dream forgetting feels so arbitrary. There's no reliable rule for which dreams will be remembered. Lucid dreamers can sometimes perform experiments in their dreams and remember them afterward. In lucid dreams, where the dreamer knows they're dreaming, some people can deliberately perform tasks or tests. They might try to read text, look at their hands, or fly. A 2025 study using data from multiple labs showed that during lucid dreams, brain regions associated with metacognition and self-awareness activate more than in regular dreams. This increased awareness seems to engage memory systems more effectively. Lucid dreamers report better recall not just of lucid dreams, but sometimes of non-lucid dreams too. The practice of lucidity may train the brain to maintain more continuity between sleeping and waking consciousness, reducing the barrier that usually causes dream forgetting. Dreams occurring during daytime naps are often forgotten even more readily than nighttime dreams. Nap dreams tend to be shorter and occur during lighter REM periods. Additionally, the transition from nap to waking is usually abrupt, with the person moving directly into activity. There's no gradual awakening period that might allow dream memories to stabilize. Nappers also tend not to expect or value dreams from naps, so they pay less attention. This demonstrates how context and expectation affect dream recall. Nighttime sleep is culturally recognized as the time for dreaming. Naps are seen as quick rest periods. This framing influences whether we attend to dreams that occur during them. The sleeping brain shows patterns of activity that mirror waking experiences. But this replay doesn't require conscious awareness. Researchers can detect when a sleeping person's brain is reprocessing memories from earlier in the day. The hippocampus replays sequences of neural firing that occurred during waking. This is thought to be how memories get consolidated. Dreams may reflect this replay process, with our conscious experience forming narratives around the reactivated memories. But the consolidation work happens whether we experience dreams or not, and whether we remember them or not. The conscious dream may be an epiphenomenon, a story our awareness tells while the real work happens unconsciously beneath it. Certain natural supplements and herbs are claimed to enhance dream recall, with mixed scientific support. Vitamin B6, galantamine, and mugwort are commonly mentioned. Some studies suggest these substances can affect sleep architecture or neurotransmitter systems in ways that might influence dreaming. However, the evidence is limited and inconsistent. What does seem clear is that any substance that affects sleep can potentially affect dreams. This includes obvious things like caffeine, alcohol, and medications, but also dietary factors. The brain's neurochemistry during sleep is delicate, and anything that alters it will ripple through to affect dream generation and memory. But no supplement has been proven to reliably improve dream recall for everyone. Some dream researchers believe dreams provide a kind of threat simulation, preparing us for dangers. According to this theory, dreams often contain threatening elements, being chased, falling, failing, because rehearsing responses to threats during sleep helps us survive when awake. If this theory is correct, the dreams themselves don't need to be remembered for the training effect to work. The neural pathways activated during the dream would be strengthened, improving response patterns, regardless of conscious memory. This would explain why we've evolved to forget dreams. The practice effect happens at an unconscious level. Remembering would be unnecessary and potentially distracting. We benefit from our dreams without needing to recall them. The relationship between dreams and creativity is real, but doesn't require memory. Many creative people report that ideas come to them in dreams. But for every remembered breakthrough dream, there might be dozens of forgotten ones that nonetheless influenced creative thinking. Dreams may prime creative processes, loosening associations and allowing novel combinations of ideas. These effects might persist even after the specific dream is forgotten. You wake up with a new perspective or solution without remembering the dream that generated it. The creative work happens during sleep, but the conscious mind doesn't need a record of the process, only access to the results. After trauma, nightmares can become intrusive and hard to forget, representing a breakdown in normal dream forgetting. In PTSD, traumatic dreams replay disturbing events or variations on them. These dreams are remembered with painful clarity, and sometimes they're difficult to distinguish from memories of the actual trauma. This shows that the normal forgetting mechanism can fail. When the amygdala becomes hyperactive and the prefrontal cortex's regulatory control weakens, fear-based dreams bypass the usual barriers and inscribe themselves in memory. This pathological persistence of dreams causes suffering, showing that normal dream forgetting is actually protective. We're meant to let most dreams go. When we can't, it becomes a source of distress. You might be feeling tired now. That's perfectly fine. Breathe slowly. Feel the cycles. Your mind cycles through waking and sleeping, through remembering and forgetting, through dreams and dreamless rest. All are natural. All are necessary. Like your breath. Inhale, exhale, inhale, exhale. A small cycle within the vast universe of consciousness. You don't need to hold on to anything. You don't need to remember everything. Let it all unfold in its perfect order, like thoughts arising and fading in meditation, unhurried, unresisting, simply existing. We're almost there now. Every person dreams multiple times each night, even if they remember none of it. The universality of dreaming across all cultures and all healthy humans suggests it serves important functions. Yet the near universality of dream forgetting suggests that conscious recall isn't part of those functions. Dreams do their work silently, in the background of consciousness, like so many other brain processes. Your heart beats. Your liver processes toxins. Your immune system fights infections, all without your awareness. Dreams may belong to this category of essential processes that operate best when we don't interfere with conscious attention. The feeling of having dreamed, even without specific memory, may itself be meaningful. Some mornings, you wake knowing you dreamed, sensing it, even though no content remains. This feeling might carry information, perhaps a sense of whether the dreams were pleasant or disturbing, emotional or neutral. The memory is gone, but something persists. A mood, an impression. This suggests that dreams influence us even when we can't remember them consciously. They color our waking state in subtle ways, contributing to how we feel without our knowing why. Forgetting dreams allows each night to start fresh. If we remembered every dream with perfect clarity, our minds would fill with thousands of remembered experiences that never actually happened. We might find it difficult to separate real experiences from dream imagery. The forgetting creates a clean boundary. Waking life is real. Dreams are ephemeral. This separation protects our grasp on reality. It allows sleep to be truly restorative, a time when the mind can play freely without consequences, knowing none of it will intrude on waking life. Some philosophers argue that the transience of dreams reflects the transience of all experience. Nothing lasts. Thoughts come and go. Emotions rise and fall. Even our cells are constantly dying and being replaced. Dreams simply make this impermanence more obvious. They're so brief, so fragile, that they highlight what's true of all experience. It's fleeting. By recognizing that we can't hold on to dreams, maybe we learn to hold everything more lightly. To appreciate experience without clinging to it. The dreams we do remember might not be representative of our overall dream life. Perhaps we remember only the most bizarre, the most emotional, or the ones that occurred at convenient moments. The majority of dreams, the ordinary ones, the quiet ones, might slip away unnoticed. So when we think about our dreams, we're thinking about a curated selection, not the full picture. We're seeing highlights, not the complete collection. This means our conscious understanding of our dream life is necessarily incomplete and possibly distorted. Writing down a dream can change your memory of it. The act of putting experience into words reshapes that experience. Words are limited. They can't fully capture the multisensory strangeness of dreams. When you write a dream, you simplify it, linearize it, make it fit the constraints of language. Later, you may remember the written version more than the actual dream. Your dream journal then becomes not just a record, but a transformation, a translation of one form of experience into another. The original is still forgotten, replaced by this linguistic version. Newborn infants spend approximately 50% of their sleep time in REM, gradually decreasing to about 20 to 25% by adulthood. This enormous amount of REM sleep is thought to support rapid brain development. The dreaming that occurs during all this REM presumably helps organize newly forming neural networks, but infants can't tell us what they dream, and they almost certainly don't remember any of it. This shows that dreaming in its most abundant form occurs without memory, without language, without the capacity for later recall. The work of dreams happens in darkness and silence. Occasionally, a dream memory surfaces unexpectedly hours or even days later. A smell, a sight, a phrase might trigger the sudden return of a dream you'd completely forgotten. These moments of spontaneous recall show that some dream memories do persist in hidden form, waiting for the right cue. But they're rare and unpredictable. You can't deliberately search your memory for forgotten dreams. They return only by chance, if at all. This suggests that dream memories exist in a different format than normal memories, one that's not readily accessible to conscious retrieval processes. People who experience more frequent lucid dreams sometimes report feeling tired during the day, suggesting that increased awareness during sleep may reduce its restorative quality. There may be a trade-off between dream recall and sleep quality. The very mechanisms that would help us remember dreams more vividly might interfere with sleep's primary purposes: rest and restoration. Normal dream forgetting might be the price we pay for truly restorative sleep. Too much awareness during sleep, even self-awareness within dreams, may defeat sleep's essential purpose. The experience of dreams is private and ultimately inexpressible. No one can truly know what another person's dreams are like. Even detailed descriptions fall short. Dreams resist language. They exist in a realm beyond words, made of fleeting sensations, impossible perspectives, emotional tones that have no name. This ineffability contributes to forgetting. If experience can't be encoded in language or other symbolic systems, memory has trouble holding onto it. Dreams slip away partly because we lack adequate tools to capture and preserve them. Some dream content may reflect random neural firing with no meaning. Not every dream needs interpretation. Some dreams might be simple noise, the brain maintaining activity during sleep, generating patterns without significance. If this is true, then forgetting meaningless dreams is efficient. The brain conserves resources by not bothering to remember content that served no purpose. Only occasionally might a dream contain something worth preserving, an insight, a resolution, an important emotional processing, and even then, the brain might not recognize it as worth saving. The border between memory and forgetting is fuzzy, not sharp. Some dreams are clearly remembered, others clearly forgotten, but many exist in a twilight zone. You might remember that something happened without knowing what, or remember a single image devoid of context, or retain an emotion without a story. These partial memories show that forgetting isn't all or nothing. It's a gradual process of decay, with some elements more resistant than others. Emotions tend to last longer than facts. Impressions outlast details. Your mind creates entire worlds while you sleep. Every night, during REM sleep, your brain constructs vivid experiences from memory fragments, emotions, and abstract patterns. Characters appear, conversations unfold, landscapes emerge, all generated from within. These dream worlds feel real in the moment, complete with sights, sounds, and sometimes even physical sensations. Yet they vanish upon waking like morning mist. The sleeping brain is not resting, but creating, exploring possibilities that waking life never offers. We dream about our deepest concerns, our relationships, our memories, and our hopes. Dreams weave together the meaningful threads of our lives. They revisit unresolved situations, process difficult emotions, and sometimes offer new perspectives. This emotional and personal relevance suggests dreams serve important psychological functions. Yet we forget them. The work happens regardless of memory. Your psyche processes, integrates, and heals during sleep, and the conscious memory of it isn't required. The healing happens in the doing, not in the remembering. Forgetting dreams mirrors larger truths about consciousness and memory. Most of what happens in your brain never reaches awareness. Most neural processes are unconscious. Memory is selective, preserving only tiny fractions of experience. Forgetting is normal, necessary, and constant. Dreams simply make this obvious. They're experiences that feel vivid and real, but leave no trace. They remind us that consciousness is selective, that awareness is narrow, and that most of what we are exists beyond our ability to know or remember. Perhaps the question isn't why we forget dreams, but why we remember any of them. Given the neurochemical conditions of REM sleep, given the deactivation of memory encoding systems, given the state-dependent nature of memory, the default should be total forgetting. The fact that any dreams are remembered at all might be the anomaly requiring explanation. Maybe we remember fragments only when something goes slightly awry, when we wake at the wrong moment, when the transition between states is incomplete. Normal, healthy sleep might mean complete dream amnesia. Some dream researchers study dreamless sleep, finding that even without REM, the mind remains active. Thoughts occur during non-REM sleep, though they're typically less vivid and narrative than REM dreams. These thoughts are forgotten even more completely than dreams. If dreams are ephemeral, dreamless sleep thoughts are ghosts of ghosts. Yet they happen. Your mind is never truly blank during sleep. Consciousness exists on a continuum, from vivid dreams to vague thoughts, to something approaching true unconsciousness during deep, slow-wave sleep. And almost all of it is forgotten. Dreams connect us to something larger than ourselves. Across time and culture, humans have dreamed. Ancient peoples dreamed. Future generations will dream. Everyone who has ever lived experienced this nightly journey into strange inner territories. The content varies, but the experience is universal. And universally, most of it is forgotten. This shared forgetting is part of the human condition. We all carry experiences we can't retain, knowledge we can't keep, visions that dissolve before we can grasp them. There's beauty in the forgetting itself. If we remembered everything, experience would become cluttered, overwhelming. The mind needs space. Forgetting creates that space. It allows the new to enter. Each night's dreams can be fresh because yesterday's dreams have faded. Each morning can begin unencumbered by the strange journeys of the night. The forgetting is not loss, but renewal. Not absence, but openness. Not failure, but grace. Some dreams were perhaps meant to forget. Dreams that process trauma, that work through difficult emotions, that integrate painful experiences. Maybe these do their work best when we don't consciously remember them. The healing happens beneath awareness. The integration occurs in neural networks we can't observe. Consciousness steps aside and lets deeper processes do what they do. When we wake, we're subtly changed by dreams we don't remember, shaped by experiences we never consciously held. Your forgotten dreams are not truly lost. They shaped your brain in the moment they occurred. Neural connections were strengthened or weakened. Emotions were processed. Memories were integrated. The dreams leave traces, even without explicit memory. You are, in some small way, different because of every dream you've ever had, whether you remember them or not. The forgetting is of the experience, but not of the effect. The dream's work persists. Accepting dream forgetting might be easier than fighting it. Trying desperately to remember dreams can create frustration and anxiety about sleep. Some people wake themselves repeatedly trying to catch dreams, fragmenting their sleep. Others stress over forgotten dreams, feeling they've lost something important. But what if the forgetting is exactly as it should be? What if letting dreams go is part of their nature? Perhaps accepting impermanence, even in this small realm of dreams, teaches us something about accepting impermanence everywhere. The scientific study of dreams continues to evolve. New tools, new methods, new insights emerge regularly. The 2025 studies we've mentioned, the DREAM database, the lucid dreaming research, the neural architecture findings, represent the current edge of understanding. But much remains mysterious. Why dreams exist, what they're for, and why we forget them are questions still debated. Science can describe mechanisms, trace brain activity, measure neurotransmitters. But the subjective experience of dreaming and its meaning remain in realms science hasn't fully reached. Each person's relationship with dreams is unique. Some people treasure the few dreams they remember, finding meaning and inspiration in them. Others barely notice dreams at all and don't miss them. Some wish they could remember more. Others are grateful for the forgetting, especially if their dreams are disturbing. There's no right way to dream or to forget. Your experience is yours. Whether you remember many dreams or few, whether you seek meaning in them or dismiss them, you're experiencing something fundamentally human. The forgetting is part of that experience. Perhaps dreams teach us to live in the present. They arise. They vanish. They can't be held. Like everything in life, they're temporary. Trying to grasp them tightly only makes them slip away faster. The practice of letting dreams go might be practice for letting everything go. Not with indifference, but with grace. Not with resignation, but with acceptance. Dreams remind us that experience itself is ephemeral. That now is all we have. That awareness in this moment is enough, because memory is unreliable and the future is uncertain. Dreams whisper, let go, let go, let go. And in the forgetting, perhaps, there's a kind of freedom. And so, our quiet journey through the mysteries of dreams comes to a gentle close. We've traveled from the hippocampus, quietly working during sleep, to the MCH neurons that actively erase, discovering along the way that forgetting is not failure, but function. From the chemistry of acetylcholine to the brief glow of lucid awareness, we've glimpsed how consciousness dances at the edges of sleep, creating experiences that dissolve like morning dew. Dreams remind us that experience itself is impermanent. Much of the mind's work happens in silence, below awareness, in depths we can't observe. Our forgotten dreams teach patience, acceptance, letting go. Without forgetting, there would be no space for tomorrow's dreams. By releasing what we cannot hold, we remain open to what comes next. By pausing to notice, we glimpse the extraordinary dance of consciousness, awake, asleep, dreaming, forgetting, always changing. And now, in these final minutes, Take the deepest breath you can, as deep as possible. Think about consciousness itself. Yours, mine, everyone listening, all awareness everywhere, perhaps all connected in ways we don't yet understand. You are not alone in the universe of minds. Think about how every person who has ever lived has dreamed and forgotten and dreamed again. Across centuries, across cultures, this rhythm continues. Let your entire being dissolve into the ocean of consciousness, into dreamless rest, into the space before thought. Prepare for deep sleep. No boundaries left, only peace. If this thoughtful exploration of the mind made you feel less alone tonight, whisper it forward to someone still awake. It may bring comfort to one more wandering consciousness. One quiet share, one peaceful night at a time. But there's no need to do anything now. Nothing at all. You've traveled far tonight, through the neuroscience of forgetting and the poetry of consciousness. You can allow these thoughts of dreams and memory to fade now, like dreams themselves, leaving only the gentle calm behind. Let your breathing deepen. Let your body feel heavier, as if gravity is gently pulling you deeper into rest. If sleep comes, let it carry you like a wave, smoothly, inevitably, into a realm where time and weight no longer matter. If your eyes are still open, the next video is waiting for you, ready to continue the journey. But if they're closed, stay there. Stay in the darkness that feels safe and warm. Tomorrow, dreams will still be there. Your brain will still create its nightly theater. Memory will still choose what to keep and what to release. But tonight belongs to stillness. Rest well, curious mind. And remember, your forgotten dreams are not lost. They've done their work in silence. You are changed by what you cannot remember. Fall asleep to gentle facts. Where science meets sleep, dream deeper with bedtime science. Relax, listen, and drift into sleep.